So turn to a nice clean page in your notebook. Turn to a nice clean page. We'll go get a new pencil. All right. So I'm going to put today's date on here. It is the 27th. All right, so the first thing we're going to do is we're going to look at the commutative property. We're going to look at the commutative property. So the commutative property basically states that factors can be multiplied in any order and the product will be the same. Factors can be multiplied in any order and the product will be the same. They can be multiplied in any order and the product will be the same. So you're probably like, well, what does this mean? What does this look like? Well, an example of this would be 4 times 5 equals 5 times 4. Because 4 times 5 is 20. 5 times 4 is 20. So they equal, they're the same. So it doesn't matter that the 5 is first here and it's second here. They both still equal 20. When I multiply them, they're going to come out to be the same number.
Miss Taylor, are we supposed to copy you?
Yes, please.
Okay.
It works the same way if you were to look at it in a word problem. So if a frog hops 4 times, each time he hops 5 feet, how far does the frog hop? Well, I know my multiplication sentence is 4 times 5 because those are the numbers in my word problem. Well, if they switch the 5 and the 4, I'm still going to have the same product. It's just in a different, the multiplication sentence is flipped. So if I have the multiplication sentence, 6 times 3. What is 6 times 3? Walter, what's 6 times 3?
Six times 3 is equal to 18.
Is 18. Okay, so now if I do 3 times 6, what's 3 times 6?
18.
Oh, Walter, mute. What's 3 times 6? Amira, what's 3 times 6? Katya, what's 3 times 6?
Miss Chandler, I have to go with Miss Davis.
You're good, Michael.
18.
18. So these equal the same, right? 6 times 3, 3 times 6. They both equal 18. So the product comes out the same. The product comes out the same. Okay, pretty easy, makes sense. We'll go over it a little bit more. Okay, so now I'm going to show you, okay, the associative property. It's a little bit different. It's kind of the same, but it's a little bit different.
Cut out for me again.
It's okay, Camila. For whatever reason, Zoom is just kicking you out today. So, for the associative property, it says something similar to the commutative. It says factors can be grouped in any order and the product will be the same. So in both of these, it's saying that it doesn't matter what order you put something in, the product is still going to be the same. So it doesn't matter what order you put things in, your product will be the same. So what this would look like is if I had 12 times 3, oh, whoops, let me put example. If I had 12 times 3. And I wasn't really sure about 12. I could say 2 times 6, and then times it by 3. This equals 36. This one is going to be a little hard, okay, because I know we just learned 2-digit times 1-digit multiplication, and we only did tens. So just bear with me while I go through it. I promise it's going to look really weird, but I promise we'll get through it. So if I were to write this, 3 times 12, so 2 times 6. So if I were to switch it and write 3 times 2 times 6, it still is going to equal 36. So basically, both of these are just your placement of numbers, okay? I know this one's really confusing, okay? But I mainly want you to look at just the fact that it's the placement of the numbers. Your placement of numbers is what's changing. Both of them are basically saying it doesn't matter what order you put the numbers in. If your product is the same, if your numbers are the same, your product is going to be the same. Like I said, I know this one's really weird. It looks really weird because we really haven't done anything like this. But I mostly just want you to focus on the order of the numbers. The numbers are the same, the order is just different. So the big takeaway I want you to get from this is that the numbers are the same, the order is just different. But it doesn't matter if the order is different because the numbers are the same. All right, when you're done copying, give me a thumbs up and then we'll move on to some examples. Yes, Walter.
So, aren't you going to show us the thing for the independent practice?
Are we there yet?
I don't know.
We're not there yet.
What do you mean you're going to show some examples?
Meaning I'm going to do an example with you that looks very similar to the independent practice. So we can practice, we're practicing the commutative property. We're not going to touch on the associative property because we really haven't done it yet. So we're not looking at this one. We're just looking at this one. But you need to know both.
Okay.
And then I will show you the independent practice. All right. If you still need this, I'll put it back up after we're done. Let me show some examples first, okay? So, yes, Camila, you have a question?
I can't see you, but I can mute and unmute myself for some reason.
But you can't see me?
I can't see anything.
Okay.
I
Camila.
can't see your screen.
Oh, that's weird.
And I couldn't see you either.
I can't see your screen either.
Well, yeah, you're not gonna be able to see me. Can y'all see it now? It should just be like a wood table.
Yeah, I see.
No, I still don't see anything. I don't see you. I don't see your
I
screen.
don't see anybody. Not
Okay.
even.
I don't see anybody.
Okay, hold on. Okay, listen. It's probably y'all's screen because everybody else can see. So probably what you're gonna have to do is leave Zoom, exit out, and come back. Okay? Leave Zoom, exit out, come back, and it should come back.
There's one problem. I don't see the leave meeting button.
It should be at the bottom of your screen somewhere.
Oh, now I can see it.
No, but I only see my screen. I can't even see Zoom.
I can see it, but it won't let me press on it.
Okay. Listen, girls. Okay. So let me
I
hold
found
on.
it.
Okay.
Found it. Yay.
Okay.
And
I'm gonna keep going. Y'all leave Zoom, try and come back, see if it fixes it. Because everybody else can see. All right. So 1 third grade classroom is set up with 6 tables and 5 desks at each table. The other class is set up with 5 tables and 6 desks at each table. Draw a number line for each. Write an equation for each. So, my equation, I know I have 6 tables and 5 desks at each table. Then I have 5 tables with 6 desks at each table. So I want to know what my equation should be. Well, I know my first equation is going to be 6 times 5, right? Because I have 6 and I have 5. Then my second one is going to be 5 times 6, because I have 5 and then I have 6. So now I'm going to draw it on my number line. So I'm going to start with 0. I'm going to go 5, 10, 15, 20, 25, 30, 35, 40. And I'm going to do the same thing on the other one. And the reason I'm counting by 5s on my number line is because we are multiplying by 5s. All right, so I know I have 6 groups of 5. So that means I need to jump 6 times. So I'm going to start at 0. 1, 2, 3, 4, 5, 6. So I got 30. Thumbs up, do you agree? 5 times 6 equals 30? Thumbs up, do you agree? 5 times 6 equals 30? Okay. So I'm going to do the other side. Well, this one, since I'm still counting by 5s, I'm going to need to jump 6 times still. So 1, 2, 3, 4, 5, 6. Oops, I overjumped. Okay, so 5 times 6, do y'all agree? 5 times 6 equals 30? Okay? What do you notice about this situation? What do you notice? Katya, what do you notice?
They both have the same answers.
They both have the same product, right? They both have the same product. They also have the same, that word that starts with an F that these are called. The Miss O'Don taught you probably. Grace?
They have the same factors.
Good, they have the same factors. They have the same factors. So we notice they have the same factors. They have the same product. Well, what's the only difference between this equation and this equation? Walter, what's the only difference between this equation and this equation?
That they have the numbers are in different positions.
The numbers are in different positions, right? The numbers are flipped. So I'm going to write down here, I noticed the factors.
You won't notice, Miss Chandler. You don't notice.
Products. Huh? I noticed, sorry, the factors and products are the same, but the factors are in a different order, right? I noticed the factors and products are the same, but the factors are in a different order. So they're the same, they're just in a different order. So for your independent practice, you're going to do the same thing. You're going to have something really similar. You're going to have one that's going to ask you to draw a number line, and then you're going to have another one that is going to tell you to just show your problem in your own way. So you can either do equal groups, you can do array, area model, repeated addition, whatever strategy you want on the second one. The first one, I do want you to do the number line, but then on the second one, you can do any of the other strategies that you want. Yes, Katya?
They're gonna be on Seesaw, right?
Yes. Okay, so I'm going to show you the activity on Seesaw. So the activity is called multiplying using properties. Okay, so you'll have one problem and then the other problem. So this is the first one that this one wants you to draw your number line. Okay, on the second one, on this one, you can draw whatever model strategy, you can do whatever you want on this one. Okay, doesn't matter to me what you do. Whatever is easiest for you. You can use whatever strategy you want. So I'm going to read both questions to you, okay? The first question says, one third grade classroom is set up with 3 tables and 7 desks at each table. The other class is set up with 3 tables and 3 desks at each table. Draw a number line for each. Write an equation for each. Okay, so that's problem number 1. Problem number 2 says, 2 delivery companies delivered 6 packages to 4 houses on Choir Lane. Model the problem 2 different ways. Draw a model and write an equation for each to show how many packages were delivered to Choir Lane. So on this one, right, you're going to write 1 as the equation one way, and then just like I showed you, you're going to flip it on the other side. Okay. Does anybody have any questions? Yes.